So next class, continuous random variable. It is third class. So in previous class, definition of random variable and types of random variables. And in last class, we discussed the discrete random variables. We solved the two problems in discrete random variable. Now continuous random variable. In continuous random variable, mean. So mean is equal to formula. Mean is equal to integration minus infinity to infinity x into f of x dx. It is mean or expectation e of x. E of x. So e of x means it is also a mean value. So next variance. First formula is mean. Second formula variance. Variance is equal to, so that means sigma square is equal to integration minus infinity to infinity x square f of x dx minus mu square. It is the variance formula. Okay. So next continuous random variable లో ఒక ప్రాబ్లం సాల్వ్ చేద్దాం. దట్ మీన్స్ ఏ కంటిన్యూస్ ర్యాండమ్ వేరియబుల్ x as the probability density function f of x is equal to k into x into e power minus lambda x for all x greater than or equal to 0 and lambda greater than 0. So otherwise 0 condition. Find k value. That means second problem mean, third problem is variance. So we know that variance is continuous random variable sigma square is equal to minus infinity to infinity x square f of x dx minus mu square, and mean is equal to minus infinity to infinity x into f of x dx. It is mean. So first how to find k value. So we know that so integration minus infinity to infinity f of x dx is equal to 1. We discussed this formula in previous class. So that is, so total minus infinity to infinity, that means minus infinity to infinity f of x dx is equal to 1. So here limits x greater than or equal to 0. So first x greater than or equal to 0 limits x greater than 0 remain. So in first minus infinity to 0 f of x dx, next 0 to infinity f of x dx is equal to 1. So given here in problem x greater than or equal to 0 one function and other cases is 0. So divided into two parts in given limits. So that means so this value is 0 plus, so otherwise this value is 0 plus. So next 0 to infinity, that means k into x into e power minus lambda x. So dx is equal to 1. So next integration, k is constant, integration of 0 to infinity, so x into e power minus lambda x dx, so is equal to 1. So apply the integration. So here apply the integration, that means using Bernoulli rule. So integration of u into v dx is equal to u into v1 minus u dash into v2 plus so and so values. So that means u means first value. So next v means integration of v, it is u value, it is v value. So v1 means integration of v. So next derivation of u. Next v2 means integration of v1. So next u double dash into v3. Symbols first start with plus, next minus, plus alternate values. So therefore k into integration 0 to, so that means first x into integration of e power minus lambda x means e power minus lambda x by minus lambda. So next second minus u means 1, x means 1, derivation of x into integration of this value is minus lambda x by minus lambda into minus lambda, that means lambda square, so is equal to 1. So next k into, so apply the limits here 0 to infinity, this value x means this value is 0. So next upper limit 0 and lower limit is 0. So next here upper limit is 0, minus 1 into infinity applies to now, so it is 0, lower limit. So that means e power minus lambda x is equal to 0. E power, that means e power 0. E power 0 means 1 by lambda square. So is equal to 1. So therefore k into, so minus into minus plus 1 by lambda square is equal to 1. So therefore k is equal to lambda square. K is equal to lambda square. Okay, right. So next mean, in this problem we calculate next mean. So that is equal to, mean is equal to mu or expectation e of x is equal to in continuous random variable. So that means integration minus infinity to infinity x into f of x dx is formula mean ku. So therefore mu is equal to here also same, minus infinity to 0 f of x dx. So minus infinity to infinity divided in two parts, that means first part is minus infinity to 0, second part is 0 to infinity. So therefore plus second part 0 to infinity f of x dx. So next substitute mu is equal to integration, this value is 0 to minus infinity to 0 is function is 0 plus 0 to infinity f of x into f of x, sorry, x into f of x. X into f of x means f of x is equal to lambda square into x into e power minus lambda dx. So mu is equal to, here lambda is constant, side cross and 0 to infinity x into x square into e power minus lambda x dx. Here also apply the Bernoulli's rule, using Bernoulli rule. So therefore mu is equal to Bernoulli rule means uv, integration of uv dx is equal to u into v1 minus u dash into v2 plus u double dash into v3, so and so values. So first integration of 0 to infinity x square e power minus lambda x. So apply the integration x square into e power minus lambda x, that means e power minus lambda x by minus lambda. Second x square derivation, that means 2x into again this value, it is u value, it is v value, this value, integration of this value, that means e power minus lambda x by lambda square. So next plus, first plus, next minus, again plus. Here derivation of 2x is 2, derivation of 2x is 2 into e power minus lambda x by minus lambda cube. So limits 0 to infinity. So therefore mu is equal to lambda square, into, so first infinity applies, that means 0, so 0 applies na 0. So here also same, next here also same, that means infinity 0 next 0. Okay, next infinity apply చేస్తే 0 0, next 0 apply చేయండి, that plus minus lower limit 2 into, so e power 0 by minus lambda cube. So therefore lambda square into total value, so 2 into e power 0 means 1 by minus lambda cube, so minus minus cancel. Next so lambda square 2 cancel, 2 lambdas cancel, therefore remaining value 2 by lambda, 2 by lambda, it is mu value. Mu is equal to 2 by lambda, it is mean is equal to. So third problem, variance is equal to, so variance is equal to sigma square, so that is equal to integration minus infinity to infinity x square f of x dx minus mu square. It is the variance formula in continuous random variable. So same, sigma square is equal to same, limits divided into two parts, so therefore minus infinity to 0 f of x dx plus next part is 0 to infinity, so it is x square. So x square into f of x dx minus mu square. So next so sigma square is equal to, it is 0, f of x 0 means something is 0. So next 0 to infinity x square into f of x value is, f of x is equal to lambda square into x into lambda square into x into e power minus lambda x. So 0 to infinity x square into lambda square into x into e power minus lambda x dx. Again mu value is mean, that means 2 by lambda whole square. So the sigma square is equal to 0 to infinity x, here lambda is constant, so munduku raseseyandi. Next x square into x means x cube, so remaining value e power minus lambda x dx. So 2 by lambda means 4 by lambda square, 4 by lambda square. So simplify, we are using Bernoulli's rule. So sigma square is equal to lambda square into, so apply the integration x cube into e power minus lambda by minus lambda x. So next value 2x square, so 2x square into, so integration, so integration of e power minus lambda x by minus lambda into minus lambda, that means lambda square. So plus, so plus derivation of 3x square 6x into e power minus lambda x by minus lambda cube, again derivation. So minus 6 into e power minus lambda x by lambda power 4. So limits 0 to infinity minus 4 by lambda square. So next simplify చేస్తే sigma square is equal to lambda square into lambda square, limits apply అండి. సో 0 infinite apply చేస్తే next 0 apply and 0, next it is also 0, next it is also 0, here also 0, so 0. Okay, next సో ఇన్ఫినిటీ అప్లై చేసిన 0 అవుతుంది. నెక్స్ట్ 0 అప్లై అండి. -6 ఇంటూ, సో ఈ పవర్ 0 by lambda power 4. So minus 4 by lambda square. So sigma square is equal to, so lambda square into, so it is 0, so minus 6 into 1 by lambda power 4 is equal to, sorry, minus 4 by lambda square. So simplify చేస్తే sigma square is equal to, so lambda square cancel, remaining 2 lambda square, so 6 by lambda square minus 4 by lambda square, so that is equal to here plus value, here plus. So next 6, here LCM is lambda square, 6 minus 4, so that is equal to 2 lambda square. So sigma square is equal to 2 lambda square. It is variance. Okay, thank you everyone. Subscribe my channel Shekhar Reddy Maths Academy. Please subscribe.